Alright guys, we're looking at section 1.2.3, describing data distribution, and this video is going to be a lot shorter than the last one, which I'm sure you'll all be happy about. We're just going to look at different ways of describing data distributions. In the last video we talked about how to make a box plot by looking at Q1, Q2, Q3, mins and maxes. In this one we're just going to talk about what happens if you represent that data instead of with a box plot with what's something called a histogram. Alright, so single variable numeric data can be represented graphically with a combination of histogram and box plot. So here's our box plot. This is a histogram right here. When describing single variable data, consider the center, which is the mean or median, and the shape. Is it symmetric? Is it skewed, which means is more of it to the left or more to the right? Is it single or double peaked? Is it uniform? How spread out is it? What's the interquartile range? What's the standard deviation? And are there outliers that are far from the bulk of the data? We've got several examples of histograms here for you. Here we have a symmetric histogram. It's called a symmetric histogram because we could imagine there being a line of symmetry down the middle, and we can see that the left side more or less equals the right side. You could sort of fold it over that line of reflective symmetry. This is called a skewed left distribution. There's also a skewed right distribution that looks like this but mirrored. And I always try to imagine, actually I had a student in one of my stats class who imagined this one, there was a little skier and he would ski down to the left, and so he thought of skied left. So that would be a skewed left because you would ski down that direction, and if it was skewed right you'd ski down the other direction. This one we have a single peak. We have one peak right here in the middle. Here we have a double peak, one here and one here. This is sometimes called bimodal. Fancier term for it, but same thing. One peak here, one peak here. And then we have a uniform distribution, which is called uniform because it's sort of flat across the top. Doesn't have to be exactly flat, but it's, you know, basically flat across the top of the histogram. That is it as far as the sort of official math notes here. On the next slide I did just pop up some other distributions for you that the book hasn't brought up just yet, just to show you that this is something that statisticians and mathematicians really care a lot about when they're looking at data. And I'm sure that at some point we will be talking about the normal distribution, which is really the core to a lot of stats, sometimes called the bell curve, and you can see it has a little bell shape here as well. So I guess my last question will be, based on what we have talked about in class in the past, tell me why you think this one is called an exponential distribution and why you think this is called a geometric distribution based on other concepts that we've learned in class. Alright guys, have a good day. Bye-bye.